So we have a way to deposit the collateral. Okay, awesome. What should we do next? Well, the next thing that we should do is have a way to mint our DSC token, right? Once they deposit the collateral, they should be able to mint the DSC token. And then the combination of those two will be this function, deposit collateral and mint DSC. Let's go ahead and actually create this mint DSC function. Because now that they have some collateral, we should be able to mint some DSC. And now this is actually going to be a surprisingly involved method, right? Because in order to mint DSC, we need to check if the collateral value is greater than the DSC amount. And this is obviously going to involve a number of things, right? It's going to involve price feeds. We're going to be checking values. We're going to be checking a whole lot of stuff, okay? So this is actually going to be a little bit more of an in-depth function here. So let's create this mint DSC function, and we'll have this get passed in a uint256 amount DSC to mint. So people can pick how much DSC they want to mint. So let's say, for example, someone deposits $200 worth of ETH. Maybe they only want to mint $20 worth of DSC, right? So they can pick how much they want to mint here. So amount to mint here. And let's add some checks here. We should have them mint more than 0. Amount DSC to mint. This. What else? We probably want this to be non-reentrant, even though we probably don't need this to be non-reentrant because it's our DSC token, but let's put it in here anyways. It's probably all we need for now. We probably want to do some, looks like GitHub Copilot even gave me some follows CEI. Yes. Oh, that's wrong. Amount DEC to mint, amount DSC to mint, the amount of decentralized stablecoin to mint. At notice, they must have more collateral value than the minimum threshold. We're going to figure out what that means in a second. So mint DSC, we'll need to keep track of how much everybody has minted, right? So whenever they're minting DSC, they're minting debt, right? So we're going to need to keep track of that. Where can we do that? Well, we could do that as a state variable. So we'll do mapping of an address user mapped to their uint256, which is going to be an address user mapped to the uint256 amount DSC minted. It's going to be private s underscore DSC minted, like this. Now I can go back down here with this new mapping, SDSC minted, message.sender plus equals amount DSC to mint. So we're going to keep track of all that they minted. Again, this is going to follow CEI. So now we want to do a little check here. If they minted too much, for example, like they minted $150 worth of DSC, but they only have $100 worth of ETH, that's going to be way too much. We should 100% revert if that happened. So I'm actually going to make a function. I'm going to make an internal function called revert if health factor is broken with the message.sender being sent. So we're going to create this new internal function. So up here we have external functions. We're going to scroll down here. We're going to make this private and internal functions like this. And we're only going to be able to call this internally, right? So we're going to create this function revert if health factor is broken, address user. It's going to be an internal view function. And we're going to basically check health factor, which is basically, do they have enough collateral, right? And then revert if they don't have a good health factor. So this health factor is actually a term that I borrowed from the aave documentation. For each wallet, these risk parameters enable the calculation of health factor. And you can see a little bit of an image here that shows it. So additionally, we're going to need to make a function that checks the health factor. Actually, these are going to be private and internal view functions. So first we need to make a function that can get the health factor. So we're going to make another function here called function underscore health factor. We're going to take an address user. And you see we have this leading underscore to tell us as developers that this is an internal function. So let's actually give this an underscore as well. Func Oops. Health factor. This will be a private view. It's going to return a uint256. So what this health factor thing is going to do, give it a little bit of nat spec. We can say this is going to returns how close to liquidation a user is. Say if a user goes below 1, then they can get liquidated. So we're going to figure out what the ratio of collateral to DSC minted that users can have with this health factor function. We're going to be building a lot of stuff here. So in order to figure this out, what do we need? Well, we're going to need to get both their total DSC minted, right? And we're going to need to get their total collateral value, right? Not just the total collateral. We're going to need to get the total collateral value and make sure the value is greater than the total DSC minted. So we're going to have to make another function. We're going to need to get the uint256 total DSC minted and the uint256 collateral value in USD. And we're going to create a new function called get account information from that user. So we're going to do another one. Boom. Function underscore get account information like this. We're going to take an address user. This will be a private view. And we're going to return two things, uint256 total DSC minted and uint256 collateral value in USD. Two functions here. To get the total USD, that's easy, right? We just do total DSC minted equals this array, this mapping that we just created, right? We're keeping track of this exactly. So all we got to do is this. To get the total collateral value in USD, we're going to need to do some more math. So I'm going to say collateral value in USD equals get account collateral value, and we're going to pass some user. So this is going to be a different function. And we're going to make this a public function so that anybody can call this function themselves. So we're actually going to copy this, private and view internal functions, public internal view, and then we're going to do view and pure public and external functions all the way at the bottom. So we'll say private, we'll say public and external view functions. We'll do function, get account collateral value, address of the user. This will be a public view so that anybody can call it. Returns a uint256. Stay with me. I know we're kind of going down this tree. Stay with me here. We're about to go even further. Now to get the actual value, what do we need to do? Well, we need to loop through each collateral token, get the amount they have deposited, and map it to the price to get the USD value. So we're going to need to loop through all the collateral tokens. Do we have a way we can do that? Let's scroll to the top. Well, we have a mapping of the price feeds, but we don't have a way to loop through them. So what we can do is we could just have address weth and then address wrapped BTC. We could just have two tokens like this. We wouldn't have to loop through anything. We're going to make this system a little bit agnostic so that you could deploy this with any amount of stablecoins, any amount of collaterals. So we're going to make a new state variable. It's going to be an address array, private s underscore collateral tokens. And what we're going to do is write in our constructor, when we update our price feeds with the token and the price feed, we're also going to add the tokens addresses of I to this array. Now we have this array of collateral tokens that we can loop through, and that way we can calculate how much value people have based off of all of the tokens. So get account collateral value, we're going to say for uint256, I equals 0. I is less than s collateral tokens dot length I plus address token equals s collateral tokens of I, and we'll get the amount. So this is the token that we're working with. We'll get the amount by uint256 amount that is deposited by this user by s underscore collateral deposited user token like this. Then total collateral value in USD plus equals, now that we have the amount, we're going to need to get the USD value of this. And this is probably a function that we're going to want to have be public so that other people can use this as well. So create a function, get USD value, where somebody passes in an address token, UNT256 amount. This will be a public view, returns UNT256. And this is where we're going to do some price feed stuff, some stuff that's very familiar. So we're going to need to get the price feed for the token and then times the amount by the price. So we're going to have to work with aggregator v3 interface again, that Chainlink data feeds. So import, and I know we've worked with this before, aggregator v3 interface from, it looks like GitHub Copilot's got my back at chainlink/contracts, blah, blah, blah. This means we're going to have to install that. Remember, we can install the smaller one with forge install smart contract kit /chainlink brownie contracts at 0.6.1 -- no - commit like this. Chainlink brownie contracts. Awesome. Then we're going to have to go to our foundry.toml, add some remappings in here. So we're going to put a little comma. We're going to say at chainlink/contracts equals lib /chainlink brownie contracts/contracts like that. So now we have the aggregator v3 interface. Scroll down to the bottom, get USD value. I know we've done this before. I know this is familiar to a lot of you, but we're going to say aggregator v3 interface price feed equals aggregator v3 interface of s_price feeds of the token. So we're going to get the price feed of the token we're looking to get the value of. Now we have the price feed here. We're going to do this. Wow. GitHub Copilot. Spot on. We're going to get the price by calling price feed.latest round data. And this is where we're going to do a little bit of math, right? Let's say 1 ETH equals $1,000. The returned value from CL will be 1,000 times 1E8. How do I know this? Well, if I go to docs.chain.link, go to data feeds, I can scroll down to price feed addresses, and I can see if I do show more details for ETH-USD, ETH-USD, it has 8 decimal places. And I know Bitcoin USD also has 8 decimal places. We could add some code in here so that we make sure we're getting the right decimals, but I'm just going to go with 8 for now. And now we can do a little bit of math here. So we're going to need to do the price times the amount, right? But is this all we need to do? Return price times amount? No, because the number is going to be way too big, right? Let's say the price is 1,000 times 1E8. And now we're multiplying that by, let's say the amount is 1,000 times 1E18, because it's going to be in way. This number is going to be absolutely massive, right? So first, we need to multiply this 1,000 by a number to get this number to match this one. So these need to be the same units of precision. So that's going to be, we're going to have to multiply this first by 1E10. And because I don't like magic numbers, we're going to scroll to the top, create a new state variable right in here. We're going to do a uint256 private constant additional feed precision equals 1E10 like this. And now it's not a magic number. So instead of doing this now, we're going to say, okay, price, and we're going to wrap it as a uint256 so that everything's now in 256. We're going to say the price first needs to be multiplied by the additional feed precision so that now both of these are uint256s and they both have 1E18. But then we're going to have to divide all of these by 1E18 as well so that this number doesn't look super wonky. So we're going to have to wrap this whole thing by 1E18. And as I hate floating magic numbers like this, so we're going to scroll back to the top, copy paste this. This is now just going to be called precision 1E18, grab precision, divide by precision. So uint256 price times additional feed precision times amount divided by precision, and we should be good to go here. This is where my brain immediately goes, okay, definitely need to write some tests for this. So once we finish going through this, we're definitely going to write some tests, at least for get USD value here. So let's go back up through our massive tree of functions that we just created that are not complete. So let's go back to get account collateral value. And this is going to be the total collateral value in USD. It's going to be get the USD value of the current token we're on times the amount that we're working with. Total collateral value in USD. Actually, let's put that there. Boom. And that's it, right? So we just loop through all the tokens in the token array, and we just add up the value in USD of each one of these tokens. And I know we don't need a return here, but I'm going to add a return here anyways. Return this. So cool. So now we have a way to get the collateral value in USD. We needed that way up here. Oops, let's do collateral value in USD. Get collateral value. Oops, let's do this. And awesome. So now our get account information is going to return the total USD minted, the total DSC minted, and then the total value of all the collateral here. Okay, great.